Hello. Hi guys, good morning. Welcome back to a new video. Ki hal chal? I hope you guys are doing good. In this, we're gonna see a problem making largest island. It simply says that you are given an n cross n binary matrix grid. Binary matrix is a matrix which has values 0 and 1. 1 represents, okay, I have a land there, and 0 represents nothing. Now, the task here is I am allowed to change at most one of the zeros to ones. Again, please make sure there is a very important significance of this at most value. I'll tell you later on, but again, remember that. Now, you have to return the size of the largest island in the grid after applying this operation. Basically, an island is a four-directionally connected group of ones. So, obviously, again, these are very small examples. Let's take a very big example. Okay, big example. Now, if I ask you a very simple problem, not even this, like very simple problem, what is the current islands in this problem? Okay, you will say, Aryan, one of the island is this one, true. Another is this one, true. Another is this one, true. Another is this one, cool. So, what is the size of this island? It is 8. This one is 7. This one is 5, and this one is also 5. How do you find the island size? Simple. Run a DFS or a BFS. I can simply run a DFS. The DFS will visit all the cells. What all cells were visited, that is correspondingly my size. Cool. Now, your task is to try and see. Okay, can I make this node? Because see, all these empty nodes are the nodes which are 0. So, can I make this node a 1? Is a question. And after making it, can the component size increase? Because right now you will see the current component size maximum in this entire graph is 8. Because this is 8, this is 7, this is 5, this is 5. This is the maximum, which is 8 right now. You have to maximize it. So you will try changing at most one. So either you will change this one. Again, by default, if you did not change anything, it was 8. But let's try changing one of them. Let's see if I change this one. Okay, then I have to go and find, with changing this one, run the DFS again, and find, will the component size increase? Then again, make it and do, like, make this as 1, and then run the DFS again. Will the component size again increase or not? Because now, why you might ask, you might ask, Aaron, why run the DFS again? Because let's say if I change it to 1, now if I run the DFS again, this everything is connected. As you can see, everything is connected. And that is the reason I have to run the DFS again. So, which means that I have n square cells. Changing every cell, on every cell change, running the DFS again. Again, because running a DFS is visiting every cell. So, this is changing one cell to 1. I have n square such cells. On each cell change, you will run a DFS which can take n square time. Thus, the complexity will be O of n h power 4. Will it work? Not really. Actually, not really. Again, the n h power 4 is 5 raised to power 4 into 10 square into 4, which is like pretty bad. So what to do? Okay, no worries. Let's take and leverage. So basically what I realized is, if I replace it by 1, now I have to find a new component size. How can a component might be impacted? If any cell is replaced with 1, the component how can be impacted is, if let's say there's a different component here, different component here, different component here, different component here, I'll just simply add it and add a 1 also, because I want the size of new component. So what I did, if I placed a 1 here, I will check, okay, what is the component here, what is the component here, what is the component here, and then okay, I know 1 I have added, so 1 plus this one, which is 7 plus 8 plus 5. Now you might ask, okay, Aryan, because you changed this to 1, this is the size of new component. True. But to find this entire size, you have to iterate on it again. Yes. So it is technically still O of n square to check, which means to change one of these cells to 1, and then finding the size of the connected component, you have to again change it to 1. Yes. So how to resolve this? Obviously, with the pre-computation. What is the pre-computation? Pre-computation says that, okay, now I know that when the 1 was not here, I had green color, I had blue color, and I had a pink color. So blue color says the size was 8, right? The pink color says the size was 7. And the green color says the size was 5. Now, as soon as I placed a value 1 here, I will check its 4 neighbor cells. 4 neighbor cells will indicate me what all colors are there. Okay, I have a pink color, which means if I have a pink color, which ultimately indicates I have a component of size 7. If I have a blue color, I have a component of size 8. I have a green color, but that is twice, which means the same color is coming up and I should count its component only once. I cannot add 5 twice, no, because same color indicates that same component is actually stretching onto two sides of my cell, and thus I will count this. So with the pre-computation which I did in the previous step, when I was finding out the component size, I will also give them a color. Okay, for this color, this is the size, this color, this is the size. And for every change, which means, okay, if replacing this 0 with a 1, I will check its neighbors. And based on the color of the neighbors, I know what is the corresponding component size, or you can say island size. And with that, I will be good to go. And again, just to reiterate, if I let's say change the color here, I will see, okay, this is a 0, this is a 0, which means it doesn't have any color. Okay, it has a color, it has a color. Oh, awesome. What is this color? Color is a green. Okay, size is 5. What is this color? This color is a, let's say, a different pink whose size is 5. Again, like, a different color, let's say. And thus I will know 5 plus 5 plus 1 is a new component size if I would have replaced this cell 0 to a 1. And this I will try for every cell. So what I realized, firstly I will do a pre-computation. Okay, now let's do a dry run of what we actually did. So in the very beginning, I will have a corresponding, like simple DFS. Now what the DFS will do, this DFS will try to say that, okay, bro, visit all the cells, get me the component and also its size, which means color and size. So I will store with, like, in the form of island size, right? Again, there are multiple ways to solve it. You can solve it with another map also in multiple ways, but when I solved it, the code was very, very, very big. Again, like, it's significantly bigger. So when I saw one of the codes on Leetcode discuss, it was pretty short and small. I love that. Again, I will tell you the catch there, but yeah, it's pretty sweet, short and simple. Let's see. So firstly, we have the corresponding island size. Now this represents that, for the index 0, 1, 2, 3, 4, 5, 6. So I can say that this is one of the colors. This is the next color, next color, next color, next color, and so on and so forth. Now, in the very beginning, obviously, the matrix itself will be filled with 0 and 1. So matrix itself is filled with the values of 0 and 1. So rather, let's not choose these two values as a color. Let's assign the value 2, 3, 4, 5, and 6, and so on and so forth as the color values. So this will help me to mark it as visit also. How? Let's see. So firstly, I will say that, okay, let's visit the first component. Again, a simple DFS. What I will do, when I am visiting it, I will replace the corresponding color. And again, you see I am replacing the color. This is the color I have replaced. On the same hand, I have to make sure that I'm not visiting it. And this will also help me not visit it, right? If the thing is colored, and you see the color starts from 2 to like 2 onwards, and by default values are 0 or 1. So if it is not a 0 or a 1, which means it is already colored, and which means it is already visited also. So this is how I can get rid of it. And when I was iterating on it, I could know what is the size of this component, right? And I can simply say, okay, this is the size of this component is 7. So for this color 2, the size is 7. Let's proceed forward. Okay, again, it's a simple DFS which I am doing. Now let's visit the next one. So now I'll give him a different color. Let's say 3, 3, 3, 3, 3 and 3, 3, 3 and 3 and 3. Now with this, again, the component island size will be 8. It's a simple DFS I did again. Then another DFS I will do again. I'll keep on doing a DFS if I have the corresponding color. Let's say 4, 4, 4, 4 and 4. You see that I'm changing the grid, although it's not a good practice. But when I will show you the code, it will actually make sense that Although in the space complexity, I will take this in consideration that I change the grid. So technically I have to make a copy of grid, which is, just to save the input data intact. But at the same hand, even if I change the grid, I will easily be able to retrieve the cells back. How? Because all non-zero values are the ones which are replaced with different color itself. Okay, so here I replaced it was the 5, and again let's say if I change this also, for the color 5, it will be a size of 5. So this is how I can make my island size, which will represent index is the color and my values are the component size, or you can say island size. Now when this is done with the help of a simple DFS. When this is done, now I will go on to every cell, right? Every cell. As I go on to every cell, let's say if I go to this cell, then I will try to change this cell to a 1. So I will go on to its neighbors, this one, this one, this one, and this one. And I will extract out distinct colors. Okay, distinct colors are 2 and 3. Okay. Then for these distinct colors, for again one of like add 1 because of this current cell change, so add a 1, and then for this distinct color, which means for 2 add a 7, for 3 add a 8. Again you saw that I did a distinct colors and then added it because so as to not, or so as to get rid of repetition. Same way, let's say if the cell would have been this one, if I would have changed it, then I will go to neighbor, 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 distinct. Again, as you can see that if this is a grid, this value will be a 0 0, right? So distinct colors, if I will go and try to find it, it will be 0, 2 and 4. So again 0 has no consideration, so either you have to ignore it or put a by default value of 0. That's one thing. Okay, then I will do the same thing. I'll put a by default value of 0, and then I will grab a 0 for this. For 2 I will grab a 7, for 4 I will grab a 5, and then 1 for the change, this one. Cool. And let's say last thing, if I just show you, if I do a change of this one, then distinct colors surrounding it are 2, 3 and 4. So 1 for myself, which is this specific cell, and 2, 3, 4 neighbor values 7, 8, 5. 7, 8 and 5, and that's my answer. Cool. Let's see the code. Exactly same. So firstly, as I showed you that I will simply go, if a cell is a 1, which is it's a land cell, then I will start my simple DFS from that cell, and this is the current color. If you know, in the very beginning I have given this as the corresponding size, which ultimately says that index 0, 1, 2, 3, 4. Again, so far this is not there, so these are the indexes and these are the values or the sizes. So again, although I don't need this, but technically I am saying that for a value or a color of 0, the size is 0, because you saw that this is how it is needed here. Again, 1 will not be required because 1 will be automatically changed to a different color. Then as I am about to put a new color, I will know the current size. The current size of the grid is, or the matrix is, vector is 2. So the next color will be 2. And this is what I actually placed here. With giving the current size actually tells the next index coming up, and which will be my next color. Then I will simply say, okay, just do a DFS. DFS will simply go, firstly, again, forget about this thing. This ultimately says that if that cell is not a 1, which also means if that cell is not a 1, if it is a 0, see, this means if it is not a 1, which means it can be either a 0 or a value not equal to 1, which is 2, 3, 4 and a different color. If it is a color, it says it is already visited. If it is a 0, it is a water cell. So if it is a 0 or if it is visited, which means if it is a water cell or it is visited, don't visit it, obviously. So if it is a 0 or water cell, don't visit it. If it is a land cell, only then come inside. Cool. So this is how seamlessly, in just very small piece of code, it actually solved it. And that is what the beauty is. Again, for this code, the only change will come up here, how you handle this condition. Now, firstly, I will assign the current grid, which has a value 1. I'll assign it with a color, which I passed in by this index of island. This is the color, and I'll assign the color. Again, you might say I'm overriding the value. Yes. So for that, you can compensate by making a copy of it. Then I have to go and check the top row, bottom row, left row, right row, and then add a +1 to it. Again, this is a bottom row, this is a top row, this is a right row, this is a left row, but I have checked 4 directions and then add a +1, right? A simple thing. How you will find the component size. That is it. And then this will give me the corresponding component size. Again, this return will give me corresponding component size, and this component size, I will store it in the current index too. Cool. And then next time, let's say if I store the index value as 5, which means the component size is 5. Next time, the size of this vector is 3. So next index which I can assign the color to will be 3. And then put it back. This is how I can go about it. So considering let's say this thing is built, my vector is built of island sizes, it will have for every color what is the component size. And because of the DFS, I've also replaced each grid value of 1 to a different color also. Then the fun part starts. Go to every cell. If it is a 0, only and only then you can change it to 1. Then I went ahead and find all distinct values, which means for all my 4 neighbors, I grabbed out the corresponding value. And what that value will be, again, simply check if it is not bounded. If it is not out of bounds, then simply return the corresponding grid value. Again, this grid value here would have been either 0 or 1 or colored. If it is a 1, obviously this will be erased when we have done the entire DFS for all the components. So after doing a DFS, 1 will be gone, only 0 or color will be remaining. If it is a 0, it's a land cell. If it's a color, it's a color cell. So I will have a check and I will simply assign the corresponding different color values. Again, even if 0 comes up, still it will not impact us because by default we have put a component size for a color 0 as 0. Then when this is done, I will have why I took an unordered set because I want distinct colors. Then I will have distinct colors. New size will be 1 for myself, which means, as you remember, there's 1 0 cell which I'm about to change, and then the other are the neighbor cells. So 1 is for myself, and then for all my neighbors, I will get its corresponding island size for that color. Simply add in my current size. And again, you know that you have to try for all the possibilities of row comma column, which means change all and try to change all of the grid values. So make sure that you are maximizing your maximum size. Now, you might be in a hurry to return this answer and you might do that, but remember about one thing, that here the corresponding your new size, again, if you see the maximum size, if you go up, the maximum size is initialized to 0. So if there is no 0 cell in the grid, this maximum size will never come inside here. So no 0 cells, it will never come inside here, and thus nothing will change. What will happen because of this? Because of this, obviously, you will realize that it will only happen when everything is a 1, right? Everything is a 1. In that case, no 0 cell, you didn't came inside, maximum size still remains 0, and that is a culprit. Thus, you should have to make sure that if the maximum size is 0, which means all cells were 1, in that case, your entire grid is actually 1 component. And thus, the size will be n into n, right? N into n will be the size. Rest, if you have any one cell which is non-zero, which means obviously it would have come inside, and thus you can easily return the answer. Cool. Bye-bye. Take care. Again, if you want to practice DSA in a structured manner, again, there's a list of a lot of questions here, but everything is structured. You can come check out here. 700 problems. Again, this is entirely for practice. Because see, doing a sheet, all that stuff, great. But practice is very important. Again, come here and start solving the questions. Questions are a lot, as you can see, 63, 23, 17, oh god. But yeah, that's entirely for practice. Bye-bye.